All right, Sergio. So our customers usually appreciate when we tell them what's causing the issues. So here's just a short video that's going to explain it in further detail. So first, there's different layers of soil and how it's leveled out over time. So you have your glacial deposits, your wind. So this is like soil that's actually been carried by wind, along with erosion and fill soil. So the earth, the layers is kind of like a crust, or like a, you've heard like the earth's crust before? It's like a birthday cake almost. There's different types. The one at the bottom, it's called bedrock. It's gonna be the most stable. How your house is made, they basically are just going to dig a hole in the form of the foundation, then pour in the footing, pour in the foundation wall. On top of that, they're going to build a floor framing system. On top of that, what happens next?
My home gets built.
Your home gets built. Boom, there it is. Wow. Pretty crazy, right?
It is.
Seems simple enough. So, obviously, when they dig out the hole to build the foundation, they're going to fill it in with backfilled soil. This is like active soil, and you have your native soil underneath, hasn't been touched. This is a different part of the active soil here that's shown. So this is soil that's prone to moving and usually does move pretty much most of the time. So this is what we have to worry about. It's probably what's causing the issues here. So there's actually 3 different types of settlement. The first one is uniform settlement. You can picture like an elevator. It goes down all at once. It's pretty hard to notice. It's also extremely rare. So I don't think this is one of the causes or types of settlements rather. So as you can see, the whole house just basically just goes down as a whole. Super rare. Next up, we have tipping. This is when your house will actually tip forward, backward, side to side. Also pretty rare in this area. The main thing that we see though is differential settlement, which is probably what you're experiencing. It's when one corner of the house is actually sinking and the other part of the house is pretty secure and solid. Now we have seen some warning signs. Obviously you have cracks in the bricks, cracks in the walls, and then you have that sloping floor in the living room as well that we looked at. So there's 3 reasons. Dry season, so this loose backfill soil is going to dry up and crack like a sponge almost if you leave it out. And it creates all these voids and valleys. So your foundation has to go somewhere, right?
Sure does.
Of course, when that happens, it's going to be filled with water when it rains. As you can see here, water's pretty lazy. It's going to follow the path of least resistance, meaning it'll travel down all the highways and create a mud puddle under your footing, and then cause that to sink. If you ever to step your foot in a big mud puddle or drive into like a mud puddle with a car, it's just going to sink, right? The more pressure you put down, the more it's going to sink. Thirdly, you have poorly compacted soil. So when the foundation was actually poured, the soil, the loose backfill, wasn't compacted properly. So this could easily wash out the dirt around a foundation wall. Now, we don't really know which layer you have your house sitting on. We usually want it on bedrock. That's the most stable. So it might take some, and then we have here, just again, 3 different types of settlement. Everything makes sense so far?
Yeah.
Awesome. So just to summarize what we just saw, what kinds of soil do you think the house is on?
It looks like compromised.
Compromised, yeah.
Or poor soil.
Poor soil, probably. That's probably the root of our cause. And then based upon like the age of the home and the damages, what we've observed as well, what do you think is causing the settlement?
I don't know. I'm assuming obviously that the voids underneath you were saying what it's called, a footer or something like that?
Yeah, footing for sure.
Okay.
Yeah, so if there's a void, it's like an air pocket and your house is super heavy, it's gonna travel down that hole and sink. Good job. And then based upon the video that we just watched, what's the only way to permanently fix an issue like this and permanently stabilize it?
From what I was picking up, it sounds like we're trying to get down to that bedrock, right?
100% right. Spot on. So next, we're just going to take a look at the historic options for repair. The first one is concrete and steel concentric piers. Have you heard of these before?
I've heard of the concrete piers.
You have?
Actually, no, yeah, I could be wrong. I've probably heard of piers. I'm thinking of piers like on the ocean, like boat.
Oh,
piers.
okay, yep, okay.
No,
So
I haven't.
there's two different types, concrete. They're both made with concrete. One's just outlayered in like steel. The thing with concrete though, have you ever tried to push a soda can into like the solid ground?
No.
No?
No.
I personally haven't either.
Yeah.
Some people have.
Okay.
But picture it. Like if you were to go outside right now, push that soda can in, how far would you be able to push it?
I mean, I think the can's gonna crush.
Exactly.
Yeah.
So the same exact thing usually happens here. And then on the actual steel concentric piers, just picture if you were to take let's say a paper clip, you unwind it, and you push that into the soil. What do you think is going to happen?
It's probably gonna bend.
Exactly. So same thing happens on both of these. The other issue, they don't even reach the bedrock. So there's nothing to really stabilize them, which doesn't address the issue, which is...
my compromised soil.
You're spot on, my friend. Love it. So the second is concrete underpinning. So let's say if you called an engineer out, they might say we want a bigger footing, more surface area, similar to like if you were to walk outside when it's snowing, you have sneakers on and go right through the snow. If you had a snowshoe, you'd kind of sit on top. But what they didn't realize is your house is already sinking, right? So concrete actually weighs 100 to 150 pounds per cubic foot. So this is literally tying an anchor to an already sinking ship. So this is most of the time going to make your house sink faster.
That's terrifying.
Pretty terrifying, right? Have you ever thought about a full foundation replacement?
No. I didn't even know you could do that.
You can. I mean, if you got 60 grand to shell out.
I'm not giving you 60 grand.
Yeah, well, that's per wall.
Oh, okay.
So it's not really a feasible option, right? It takes forever too. The reason why, because they obviously have to dig out everything, put the house on jacks, disconnect all the utilities and electrical. On top of that, they have to pour the footing in. Concrete usually takes about 28 days to cure. It's 28 days for that to cure. On top of that, you have your foundation wall, which takes another 28 days to cure. So I'm sure you and your family and your two little girls don't want to go in a hotel room for 60 days, right?
I mean, the girls might.
Girls might, right?
Yeah.
What about you and the wife? Probably not.
No.
Yeah. So, based upon what we just went over, do any of these historic options for repair sound like the best solution?
No.
No, probably not.
No.
So next, I'm just going to play you a short video from our engineers that they've put together, just so they can explain it on a deeper level.
When your home starts making popping noises, cracks develop, and doors and windows stop operating properly, it can be scary, leaving you worried and wondering how to fix it. The problem is the active, unstable soil that supports your home. And many homes were built on soil that was not properly compacted at the time of construction. As this soil compacts and collapses, your home drops as well. Another major issue is the moisture content in the soil. When the soil becomes overly dry, it contracts and shrinks, creating voids. When the soil is overly saturated, it washes away or becomes too soft and can't support the weight of your home. To permanently stabilize your home, you must go beyond these active, unstable soils to bedrock, or what engineers call load-bearing strata. The settle-stop helical pier system is the answer. The system utilizes steel piers to support the home on strong soils deep below the surface. Here's how it works. First, soil is removed to expose the footing. Next, the footing is skillfully prepped for proper load transfer. The helical piers are then installed right next to the foundation and carefully monitored as they are advanced deep into the earth. And once our monitoring equipment tells us we've reached the necessary depths and capacities, a heavy-duty foundation bracket is connected to the piers and secured to the footing. The weight of your home is then transferred through the piers into competent soils deep underground to prevent future settlement of your home. Not only will your home be permanently stabilized,
We're gonna pretend this is push piers.
but there's also an opportunity to lift it back towards its original position. So, the piers rest on load-bearing strata, and the home rests on the piers. It no longer is your home vulnerable to ever-changing soil conditions. It is now permanently stabilized. And to ensure your peace of mind, we back it with a fully transferable lifetime warranty.
Does that make sense? Any questions?
So basically, it sounds like you're just gonna be drilling down to that strata, and then we're gonna be PG.
Pretty much. Pretty simple, right? So that was something showing the exterior of the home. This is a little bit of a better video for you, just to kind of expect what's gonna go on in your basement. So first, we're gonna jackhammer some of that concrete out, because obviously you're having issues with the interior mostly. They're going to attach the bracket. Actually, the bracket will be placed underneath the footing. Then we'll go ahead and install the push pier. We actually use a hydraulic press. We use the weight of the home to actually push this thing down into the ground. It's kind of like a giant nail almost, but you really can't remove it. So as you can see here, as it's pushing its way into the ground, it has this little collar on the end. This allows the soil next to it to be pushed apart as it goes down. So as that happens and they stop pushing down, all the soil will then filter back up the actual rod and prevent it from pushing back up. Does that all make sense?
Yeah.
Okay, awesome. So then we're going to put hydraulic lines linked to each one. This is pretty much at the height of load-bearing strata. How does that sound so far?
Pretty good.
Pretty good. Okay. So, I mean, based upon what we went over and the proper solution, do you think that this would be a good project you'd trust to have done at your home and permanently stabilize your foundation?
I mean, yeah, it looks pretty clear cut that we want to get down to that bedrock, and that's what this push pier is going to do. So
Awesome.